Hello, everyone, and welcome to Dr. Anum AI. I am Dr. Anum, a PhD scholar and computer science specialist. On this channel, we decode the complex world of artificial intelligence and explore how technology is reshaping our future. Let's dive into today's video. Introduction: The classical wall. Since the dawn of the Silicon Age, we have treated computing power as a linear progression. We build faster transistors, pack them tighter onto chips, and expect better results. This chart illustrates the trajectory of classical hardware. As we push into the mid 2020s, the curve begins to flatten. We are hitting the physical limits of materials and the thermal constraints of classical architecture. We are running out of room to grow. The complexity of neural networks. This struggle is most visible in artificial intelligence. Training a modern neural network requires navigating a loss landscape, a mathematical terrain of billions of possible configurations. Finding the most efficient version of a model is like trying to find the single lowest point in a mountain range that spans the entire planet. Classical computers must hike this terrain step by step, which consumes massive amounts of time and energy. The quantum shift. But as we enter 2026, a new architecture is converging with AI: quantum computing. Unlike a classical bit, which is either a 0 or a 1, a quantum bit, or qubit, exists in a state of superposition. This allows a quantum system to process a high-dimensional state space that classical hardware simply cannot map. Navigating the loss landscape. Watch how a quantum-enhanced algorithm navigates the loss landscape. Instead of trekking through every valley, the system uses quantum tunneling. It can effectively teleport through mathematical barriers to find the global minimum, the most efficient state of the AI model, almost instantly. This convergence is turning the years required for model training into minutes. The cryptographic collapse. However, this leap in power creates a structural vulnerability in our global security. Most modern encryption, from bank transfers to private messages, relies on the RSA algorithm. RSA is built on the difficulty of factoring giant prime numbers. A classical computer would take trillions of years to break a standard 2048-bit key. Shor's algorithm and the end of RSA. But a quantum system running Shor's algorithm treats this impossible task as a simple periodic search. Look at this visualization of cryptographic periodicity. The quantum system identifies the mathematical pattern of the encrypted key by analyzing all possible factors simultaneously through constructive interference. This graph shows the development timeline. As quantum hardware stability increases, the security of RSA effectively collapses. By the end of this decade, the encryption that secures the modern internet will be rendered obsolete. The future: post-quantum security. We are now in a race to develop post-quantum cryptography, new mathematical puzzles that even a quantum system cannot solve easily. The quantum convergence is a double-edged sword. It provides the computational engine needed to reach true artificial general intelligence, but it simultaneously dismantles the privacy structures of the previous era. Conclusion: The new era. We are moving from an era of classical limits to one of quantum possibilities. Success in this new landscape requires a total redesign of our digital infrastructure. Those who adapt to quantum secure protocols today will survive the cryptographic collapse of tomorrow. I hope you found this video insightful. If you are passionate about AI, healthcare technology, and professional research, make sure to subscribe to Dr. Anum AI and hit the bell icon for more expert insights. Feel free to drop your questions in the comments below. See you in the next one. Stay curious.